Okay, so like Lily said, my name is Michael Cattell. I'm a student at Penn State working in the geographics lab, and today I'm going to be talking about using GTFS files to create maps. So you may be wondering, what are GTFS files? It's an acronym. Stands for General Transit Feed Specification. So if you've ever used Google Maps or Apple Maps or some other map provider, and you've input your point A to point B, and you want to use transit, you've used a GTFS file that some transit agency has given to these map providers to tell you where buses or trains are going to be, where routes run, and what time vehicles will be making stops at certain stations. And from this, you can derive up-to-date transit stops, route locations, and derive things like frequencies from this. And so today I'm going to be walking through using SEPTA's GTFS feed because that's about where I'm from. It stands for Southeastern Pennsylvania Transportation Authority. It's Philadelphia's transit agency. So the first step is you actually have to find their GTFS feed. And usually this is pretty easy. Usually you can do something like Google SEPTA GTFS or whatever your transit agency name is. And in this case, we're going to click the first result, the API documentation. It's going to take us to this page. We're going to scroll down and go to this link here. We're going to download a zip folder. And SEPTA is a bit unique because when you download it and you download it and find it in your downloads folder, SEPTA has two different GTFS feeds in their download. They have their bus, the Google Bus folder, which is their buses, metro, subways, etc. And it also has their commuter rail folder. And for this talk, we're going to be looking at their commuter rail folder. And when you go in this folder, you're going to see 11 different files, though depending on your agency, it might be a little different. But we don't really care about all of these for this specific talk. We only care about these 7 files here: the calendar, route stops, routes, shapes, stop times, stops, and trips. And so the project, what are we going to be walking through making today? We're going to make a map of the number of SEPTA express trains that run per each route. And in order to do this, we are going to be using R, and we're going to be using 3 specific packages: Tidyverse, which is a collection of packages. I use it all the time. Tidy Transit, which is how we're going to work with the GTFS files, and then the SF package, which is how we're going to deal with the GIS side of things. And so there's a coding disclaimer. There's a lot of code in here, but I tried to break it down in a way that it is easily digestible. I also have a link to the GitHub repository I made for this that has heavily annotated code, so you can kind of see line by line what is each function doing. So if you've never coded anything in your life before, that should be okay, because conceptually it should be, hopefully it's apparent what's going on. So step 1 is probably the easiest step. You're going to load in your GTFS file. So you're going to drag your zip folder into your project directory, and then you're going to write a couple lines of code to load in your needed libraries, and then load in your GTFS zip folder. It's important that it stays zipped. It won't read in if it's just a regular folder. And then when you run this, you'll see a new object. It has a list of 12 data frames. And when you look at the names of the different data frames, you'll see that, with the exception of one, they are all exactly the files that are in that zip folder we looked at in File Explorer, except for this last one. It's a period, but that's not important. We don't need to worry about that. Step 2. Because we're looking at express trains, we're going to be looking at trips that are only running on Mondays, because SEPTA express trains do not run on weekends, and Monday is the first day of the week, so for this case, it doesn't really matter. So we're going to be using 2 of the data frames here. We're going to be looking at trips and calendar. Not in that order, though. First, we're going to load up the calendar data frame. And we're going to see that there is one row that has one service ID that has trains running on Mondays. And it's this last row. And so we want to pull this service ID column to get that service ID code so that we can use some filtering later. And so we're going to take our calendar object, filter so that the column Monday is equal to 1, which is true in this case. And then we're going to use the pull function to pull all of the values in the Monday column. And because there's only one row, it's going to be one value, which makes this a bit more of a flexible way of filtering by service ID. And then we're going to take our trips data frame, and we are going to filter so that the service ID must equal the value stored in the Monday ID variable. So this means that only trips that run on Monday will be kept in this data frame. Next thing we're going to do is we're going to get the number of stops per each first and last stop combination. So SEPTA runs a bunch of different routes, and somewhat confusingly, I suppose, there are a lot of different first and last stop combinations because you have express trains, you have trains that don't run the entire route. Sometimes in the data frame, all SEPTA trains stop in Center City, and there's 4 different Center City stations, but data's always messy, and so not all of the trains are listed as stopping at all 4 Center City stations. So we have to kind of do some things to control for that. And this is all of the code that you need in order to run this, but we're going to break through it a couple lines at a time. So the first thing you're going to do is you're going to bring in your stop times data and apply a filter so that all of the trip IDs that you ran or that you filtered previously in the Monday's trip data frame, you're going to take those trip IDs and make sure that only trip IDs in this stop times data frame that show up in the other data frame are kept. This may be a little confusing, but and then you're going to keep things a little tidy, just select a couple columns that we need: the trip ID, the stop ID, and the stop sequence, which shows the order that the train stops at stations in. Then you're going to arrange your stop sequences so that in every trip group, the stops are going to be ordered sequentially. And then you're going to do you're going to be writing over a couple stop IDs because, as I mentioned, not every train is listed as stopping in Center City, but they all do. And so this way, we're treating all of the Center City stations as one station. And there are also several stations that not every train stops at because it's very low ridership. And so a local train might stop at every other station except this one, but it'll throw off our code later. And so this just allows us to overwrite it. And then the first and last stop column, fairly self-explanatory. We're going to pull the first and last stop per trip ID group. Then we're going to bring in our trips data frame to get the direction, so whether it's going into or out of Philadelphia, and then pull only unique rows. And so by removing the stop sequence column, this allows us to overwrite every Center City station like we did before, because you're only grouping by first, last stop, and trip ID. And so there's an overwriting that happens. And then you're going to count the number of stops that occur per each group, which allows us to kind of filter out what's an express train, what's a local train, et cetera. And then you're going to count the number of occurrences for each first and last stop combination. So we can see how many variations of this route are being run. Okay, step 4. We're going to count the number of maximum stops per combination. And this allows us to figure out what is a truly local train that runs the entire length of the route. This is all the code. Going in, we're going to filter so that the stop count column is equal to the maximum number of stops for every first and last stop combination. And we're going to do a quick renaming. And then we're going to bring in the data frame that we just created and do an if-else statement to where if the stop count in a row is equal to the maximum stop count, it's going to be labeled a local, and if it's not, it's going to be labeled an express. So this is how we differentiate this. In SEPTA's GTFS file, there's no differentiating code for what is a local and what is an express train. Step 5 is where we get into some of the more GIS, the GIS side of things. We're going to get the route shapes. So what do these routes look like? So we're going to go into our shapes data frame, and you might think that this is going to be really easy because there's a shapes data frame specifically created, but it's not going to be quite as easy as the shapes data frame contains 53,000 points that are only categorized by shape ID. And so there's no way of, from this data frame alone, of determining what route each of these points belong to. So we have to do a little bit of code to work around this. And we're going to bring in some code that we wrote before, so everything that's kind of between the red lines is not new, it's copied and pasted. And then we're going to get the truly local trains like we did before, and just take, for every route, we're going to just take the first one, because they're all going to be the same, because they're all at the maximum number of stops. And then we're going to bring in our trips data frame and just keep the shape ID and the route ID columns. So this keeps the shape identification, and we can pair it up with the route IDs in a second. And so we're going to take our points data frame that we had before, that comes with the GTFS file, and we're going to turn it into an SF object, which is an R package that allows us to work with geospatial data. We're going to just put it on a Mercator projection, because that's what it's formatted on, but we're going to change it later. We're not going to keep it like that. And then we're going to run this code. Stack Overflow tells me that I have to run this summarize do union equals false. I cannot tell you why, but it simply will not run if I don't do that. So if you have any questions about that, do not ask me. Ask Stack Overflow. I do not know. And then we're going to cast our points into a line string to turn these points into a line. And then we're going to turn it into UTM projection. We're going to merge it with the route and shape ID data frame that we made before. And then we're going to bring in our express count frequency table. And then we're going to do a quick arranging to get, for layering purposes later, so that trains with the fewest express routes appear in row 1 and so on as you go down. And now we're finally at the point where we're going to make the actual map. Because this is the open source session, I just kept making this in R, though once you actually have a map, you can bring it into whatever program you like to use, whether it's Illustrator, Inkscape, whatever other graphic design software you use. So we have a color scheme. I'm well aware that this is almost certainly not colorblind safe. However, these are the old color codes that SEPTA used to have for their regional rail trains, and there's a lot of them, so this was, in my mind, kind of, for the purposes of this talk, fastest way of coming up with a color scheme. Then for one base map layer, we're going to bring in counties, and we're going to run a quick filter so that only counties in the Philadelphia metropolitan area show up. That's what this code is. And then this is a code to run a map. I simply do not have time to talk about how ggplot works, and I'm sorry about that, but if you have questions about this, come and talk to me. I love talking about this stuff, so happy to talk about it later. And then this is the fairly simple map that you get. And so this is where you would bring it into whatever other software you want, if you want to stylize it more, maybe make it a little bit better in various ways. But this map does communicate the message that the project goal, which was how many express trains run on each route. And it does that. If you would like to look at the code that I used, as I said before, the GitHub repository is there if you want to scan the QR code, or you can type in the URL. Again, it is heavily annotated, so again, I glossed over a lot of things and ran through this a little bit fast, so you can take some more time to digest that on your own. And that is all I have. Thank you.